Okay, so we're going to talk about amplitude here. So, and that might be a new word for you. Let's just look at a sine curve. 2 pi, pi, pi over 2, 3 pi over 2. Okay, and it goes up to 1 and down to -1. And the regular curve would look like, you know, points here, 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 and here. And it curves. That would be one period of a sine curve, okay? So my drawing's only so-so. Okay, that then would be sine, I'm going to put y equals sine of x, okay? Now let's have a new function, f of x equals 2 sine x. So for every output, we're going to multiply it by 2. So the output at 0, 0 is 0. 0 times 2 is still 0. I'm going to try to put it right on top here. Hopefully it'll let me. So that 0, 0 point would be the same. But now, when I had an output of 1, it's going to be 1 times 2 is 2. Yeah, 1 times 2 is 2. So I would have a point, it would move that point up there. Okay. 0, 0, or pi 0, I should say, is right there. And then -1, well, when you multiply that by 2, it's going to be -2. And then you're going to get the point at 2 pi 0 is still going to be there at 0. So your curve is going to go up steeper and come down steeper and come back. And so it has like this stretch, okay? Stretch. And we've done such things before with other functions when we were transforming them. Okay, so that would be one period of the graph. Why do they call it amplitude? I don't know. I don't have an answer for that. That's what we call it in science classes. Okay, so the amplitude, you're going to have a stretch. Oh, well, let me tell you, A is for amplitude. Okay, so this is from the form y equals A sine bx. And in this case, b was 1, so the period was still 2 pi. So that didn't change. Anyway, so if the absolute value of A is greater than 1, you're going to have a stretch. And if the absolute value of A is less than 1, you're going to have a compression. Okay? Now, we're going to talk about what's called the midline. The midline is halfway in between. So you have your highest point here, and you have your lowest point here, and then the midline is right here. This time it's right on the x-axis, okay? So that would be the midline. It's kind of where the points normally were on the x-axis. But see, later on we could have a vertical shift and the whole thing could shift up or down. And so the midline might change, okay? But it has to be halfway. The midline has to be halfway between your highest and your lowest, your extremas, your maximum and your minimum, okay? So that's where the midline will be. So here's what they tell you. The amplitude is 1/2, and then you take your maximum minus your minimum, okay? So the difference between that. So like here I have in my example with the green, my maximum was an output of 2, my minimum was -2, and we're going to take the absolute value of that, and we're going to take half of that. And so it's half of 4, the absolute value of 4, which is 4. And then half of 4 was 2, which we already knew that was the amplitude, but you can see that maybe with a different graph, it might be harder to see, okay? So that would be the absolute value of A. It's telling you what the stretch is. In this case, it's a stretch, okay? So amplitude, that's when we're talking about a vertical stretch or compression. This is vertical stretch or compression. Midline's halfway in the middle, like it's between the highest point and the lowest point, okay? And that's going to be a horizontal line, like y equals, in this case I have y equals 0. That's my midline, okay? You can find the amplitude. If you know the maximum and minimum, then you can find the amplitude with that formula. Okay, that's it for that one.